Okay, we will be doing problem number 6 from the Snell's Law problem set. So basically, Snell's Law is defined by the first equation up above, n1 sine theta 1 equals n2 sine theta 2. And basically, the values of n are called the indices of refraction, and they are defined kind of in reference to the speed of light in a certain medium. In this case, the velocity of the ratio of the velocity of light in one medium to another is going to be like inversely proportional to the indices of refraction. Thus, v1 over v2 is going to be equal to n2 over n1. And thus a different way of writing Snell's law would be v2 sine theta 1 equals v1 sine theta 2. And that's to be used in different problems like problem 3 on this same problem set. Cool. So what Snell's law describes is the situation in orange in the upper right. Basically, light comes in at a certain angle to a given plane with an angle of theta 1, and that is on the interface side, or more easily, side 1. And it goes into the new medium, or the refraction side, side 2, with a new angle of theta 2. Cool. So the problem reads, a light ray hits a surface at an angle of 86 degrees, thus theta 1 equals 86 degrees. The material on the other side of the surface has an index of refraction of 1.41, and then theta 2 equals 1.41, or sorry, n2 equals 1.41. And it comes out making an angle of 53.75 degrees, thus theta 2 equals 53.75 degrees. What is the index of refraction on the incident side of the surface? And thus we are trying to solve for theta 1. And thus we just plug everything into the original equation, solve for n1, and when you plug everything in on your calculator, you should get that n1 equals 1.14. And going back to equation 2, the second one in green with the star next to it, v1 over v2 is equal to n2 over n1. Substituting those in, the velocity of light in the first medium to the velocity of light in the second medium is actually greater than 1, meaning that light travels faster in the first medium. The problem doesn't actually define what the mediums are, but it's easy enough to just look up what these values are, or approximate values on the internet.